Hello, good morning.
Hello, good morning. Can you hear me?
Yes, I can.
Okay. So I simply share my screen and try to discuss about our code so that you can easily understand how I can develop this code for the Kuwait region for calculating the emission of methane. Yeah.
Okay.
Okay. So basically, I also recording this class for you can easily.
Perfect, because I want to review it also again. So go ahead. Thank you.
Okay. So I simply open my code editor. So this is my slide. So basically this is the course on the part of the monitoring course on Google Earth Engine platform. So mainly in this course we are observed the three monitoring parameter. So mainly drought risk index, then air quality, then water quality. So in this time I will try to focus the air quality monitoring classes so that you can easily understand. So basically when you observe the air quality monitoring using the Sentinel 5, we can easily access all of the ozone, nitrogen dioxide, sulfur dioxide, formaldehyde, carbon monoxide, methane. Okay, so basically this is our dataset link. So just I simply copy this link and just paste in a browser so that I can easily access all of the dataset which is provided the Sentinel 5 satellite imagery. So I simply open a browser and paste here. So here you can find all of the dataset for the Sentinel 5, and the Sentinel 5 you can see this is the mission for instrument that collects the data useful for accessing the air quality. The PROMOTIONAL instrument is the multispectral sensor that records the reflectance of the wavelengths important for the measuring the atmospheric concentration of ozone, then methane, then formaldehyde, aerosol, carbon monoxide, nitrogen dioxide, sulfur dioxide, as well as the cloud characteristic at a spatial resolution of 0.01 arc degrees. So here we can easily find, you can see this dataset provider is the you can see this is the dataset provider, the Copernicus. Okay, you can also see there is the lot of dataset for the aerosol index, cloud, then carbon monoxide, formaldehyde, then nitrogen dioxide, ozone, then sulfur dioxide, methane. Okay, so we can easily observe all of the dataset from here and we can easily calculate these things. I will try to show you that from my slide. Okay, so we can easily import all of this data set in here, and we can easily import, filter, reduce, clip and display this air quality data. Then if you want, you can also extract the air quality data in CSV file. Okay, so how to calculate the total emission in a particular gases, and finally how to export these tip images. We can do everything in the Google using the Google Earth Engine platform. Then if you want, you can also make the time series chart for this your particular region. Okay, if you want, you can also easily make the map layer in ArcMap or QGIS software. For the map layout, we can easily download the tip images from the Google Earth Engine, then easily import these images in ArcMap or QGIS software. Then we can easily make this map for the for making our research presentation or research paper work. We can easily make this map like this. Okay,
Yes.
so
My question is, if you
yeah,
allow me one question regarding downloading the maps. Are they geo-referenced, meaning I
yeah, this
can
is the already
directly import
geo-referenced.
them? Okay.
And mainly Google Earth Engine, here we can get all of the geo-referenced. Okay, so here we can get all of the geo-referenced file or shape file, everything, TIFF images, everything is the geo-referenced. Okay, so in this time,
Okay, because
suppose
this is, this is the first time I use Google Engine.
yeah.
I usually use ArcGIS or QGIS.
Okay, so actually first of all, if you have the beginner knowledge of the Google Earth Engine platform, how it works, I hope then you can easily understand all of this dataset, how you can easily handle any dataset. Actually this process is the same, for all of the dataset. Import, filter and everything is the same. just you know to the basic or fundamental parts of Google Earth Engine platform, and you also need to know some JavaScript programming language in here. So because you can see this is the code editor, and in this code editor we always all time write the JavaScript programming. Okay, so in this time I will try to show you the methane, this part, how you can easily import, then filter, then reduce, as well as how you can easily make the TIFF images, and using this TIFF images in ArcMap software for making the map layout. Okay, so we will start. So first of all we need to import this image collection. This is our image collection. We need to import this image collection in our code editor. Okay, so I just simply copy this Earth Engine snippet. So this is the Earth Engine snippet. I simply copy and then I simply paste in my code editor. Okay, so after this I just make a variable. Suppose I simply gave this variable is the CS4 methane, and this collection will be stored under this variable. Okay, and then I also need to add here my country boundary shapefile. Suppose in this time I want to add here my country boundary shapefile is Kuwait, and Google Earth Engine has already dataset. This dataset you provide the all country boundary shapefile in the world. So I simply search here, this dataset is called the US DOS. This is the dataset, and I simply use the simplified dataset. You can get all of the information about this dataset, and in this dataset you provided all of the international country boundary polygon. So I simply import this dataset. Simply click to import. You can see it will be imported as a default variable name is the table, and then I simply filter my specific country boundary. Suppose in this time I want to filter the Kuwait country boundary shapefile. So I simply use a variable, and then I simply get this variable name is RY. Then I simply filter my collection, and I can get from here my country boundary shapefile. It's called the Kuwait. Okay, so I simply use here the country code, and then I simply put here the Kuwait QU. Okay, and now I want to show this layer name, layer country boundary shapefile layer. I simply use here the map.add layer function. Actually in this time you can don't understand what every function, because we already cover all of this part in our beginner session. Okay, and so that I will randomly write this code, and I also want to focusing this shapefile. So I simply use here the map.center object function, and then simply put here my object name is RY, and focusing I can zoom level is the 10. Okay, then simply click to the run. So now I can get your country boundary shapefile of Kuwait. Okay, so it will appear it in our map interactive view. So now I want to, you can see this is my dataset, methane dataset. I import the dataset under this variable. So now I want to use this dataset only for this boundary, and I can get from here the methane result. Okay, okay, for a specific time period. Okay, so for this I can simply use a variable. Suppose I can simply use this variable name is the image. Okay, you can use any variable name. I simply use here the image, and then I simply call my whole collection. This is my collection, a whole collection, and it will be stored a variable. This variable name is the CS4. Okay, I simply call this CS4. After this I simply use a function, this called the filter bounds. Okay, so filter bounds, you can see this is the filter bounds, and then before this getting the filter bounds we also need to work with the band. Okay, so you can see this is our data set, and this data set has a different types of band will be available here. So in this time I want to observe here the methane column volume mixing ratio dry air. Okay, and you can see this unit is the ppb, parts per billion. Okay, and I simply copy this band name, okay, from here, and then I take a variable. Suppose I can give this variable name is the CS4 bands. You can use any variable. I just put here the CS4 bands, and then I simply call my whole collection CS4, because it is my whole collection. From this whole collection I can get only for the one band. Simply I use here the select function. This select function select only for my band, which I copied from my data information sheet, and then I simply use here this CS4. And now I want to use here the filter bounds function, because I want to get only for those images of this band which is intersecting within my boundary area, okay, of query. So I simply use here the filter bounds is the ROI, because you can see here I already put here the ROI, and this ROI stored my Kuwait country boundary shapefile, okay, it will be stored the ROI. So I simply use here the ROI, okay. So now if you want, I want to check how many images will be available between this time period. You can see this dataset will be provided this time period, year of 2019 to 2020 it will be available in here. So I want to check how many images will be available here between this time period, year of 2019 to present. So I want to simply check it. I simply use here the print function, then simply use here the image, then use here the size function. In this time you can see I simply click to the run. It will be computing. Here we can get more than 15,940 images will be available between this time period, year of 2019 to present time, okay, for my country boundary shape. Yeah.
So the number of images, is this the number of pixels or the number of days of, in this time period?
So this is the total images, okay. So suppose Sentinel 5 satellite imagery total get capturing the total images for this region.
For this region, for this period.
Yeah, only for this region we can get here the total images.
Okay.
So now these images I want to filter. Suppose I want to filter these images for a specific time period. Suppose you can see this image is the available for the between this time period, but I want to need only for those images for the year of 2020 1st January, for this month I want to need for those images 1st January year of 2020, okay. So then I also filter it. Suppose in this time I take another variable, and then I simply use here the CS4 filter date. Actually we can get any variable name, okay. I simply use here the CS4 filter date, and then I simply call this image, because this image is stored here the total 50,940 images will be stored from this, and it will be available between this time period, okay, between this year of 2090 to present time it will be available here. But in this time I want to need only for the image for the year of 2020 1st January, okay. So that's why I simply call this image and paste here. After this I use a function this called the filter bounds, okay. So this is the function. This is the filter date function, because I want to use here the filter date, and you can see it, the argument is that first date and end date. You just put here the first date and end date. In this time I simply put here the first date, suppose 2020 1st January, and end date will be that I simply put here the end date 2020 1st January, okay, 31. I can simply put here this date, and then I want to check how many images will be available between this time period, okay, for the 1 month, okay, for my specific region of query. I want to check it. I simply use here the print function, and then I simply copy this variable name and paste here. After this simply use here the size function. So I simply use here the size function, and then click to the run. So now I can get here. You can see only for the 297 images will be available for my country Kuwait, okay, for my specific boundary in Kuwait. So now I want to take, okay, now I want to show this 297 images will be not capturing at the same time of the month of 1st January, or of the month of January. It will be not just capturing the same time, okay. So it will be taken the different time of the month, year of 2020 20 January. Okay, it will be taken for the different time of this month. So now I want to check. Okay, so I simply check when image will be capturing. Okay, so I simply use here the print and then click to the run. So now I can get all of the image information when it will be captured, and all of the date I get from here. So here you can see that there are total 297 elements will be available here, and I simply click to the feature. So we can get from here all of the image list. So you can see here all of the 297 images will be available here, and you can see 0, it refers to the first item. So this is our first image, which image will be taken at this time. Here you can see this image will be taken in this time. So where you can get from here, you can see this image will be taken at the year of 2020 1st January. So this is the 2nd January, you can see 02. So this is 2nd January, and this is the another second image will be taken the 1st January. This image also taken for the 2nd January. Okay, we can get the 2nd January. Also you can see the some image will be taken at the 3rd January. Okay, also you can see there are the lot of images 4th January. Okay, we can get all of the images date, a specific date when this image will be captured for the Sentinel-5 satellite imagery. Okay, here we can get the total 297 images will be available here. Okay, so now we can use here the different types of statistical calculation between this all of the images, 297 images. We can use here the different types of statistical calculation. Suppose if you want, you can calculate the mean result. Suppose if you want to calculate the total 297 average pixel result you can want to get from here. Suppose in this time I want to try to show you that I want to calculate it from the 297 images. I want to get from here the average pixel result. Okay, so I simply use here the function. So I take a variable. Suppose I take this variable name is that I can simply use here the average variable name. You can use any variable name, average ch4. Okay, methane, and then you can see here this 297 image will be stored under this variable. Okay, I simply copy this variable and paste here. Okay, after this I simply use a function, this called the reduce function. Okay, then I simply put here the reducer.mean. Suppose in this time I want to calculate it from the 297 images. I want to calculate it from 297 images only for the average pixel value. So it will be calculated. So here you can see I use the reduce function. Reduce is a statistical function. Then I define here it will be reduces as the average. Okay, so I simply use here the mean result. So now I want to calculate this result. So here you can see from the 297 images I want to calculate all the images pixel value and get the average pixel result. Okay, so now I want to show this result in my map interactive view. So I simply use a map.addLayer function. Then I simply copy this average cs4. This is my object name. Then I click to the run. So we will try to show what's happened in our code editor. Okay, so we can see we can get the totally black and white images. Okay, it will be appeared because in this time we did not add any visualization parameter yet. So that's why it looks like this. Okay, so now I want to add here the some visualization parameter, so that's our map will be look so good. So in this time you can see in the datasheet information they are already provide the visualization parameter. I just copy from here this visualization parameter and paste in my code editor in here. So here you can see they are use the visualization parameter, and in this time they are get from the mean pixel value, it will be get the mean pixel value 1750 parts per billion ppb. Okay, and it will be start from the this value 1750 and up to 1900. Okay, between this pixel value it will be showing in this map at layer view. Okay, so in this time I simply use here this value in this. I simply copy this band visualization parameter and paste here and then click to the run. So in this time I get from here the visualization of the good visualization map. It will be appeared. Okay, so it will be appeared, but it will be not clipping with our shape file. So that's why we also need to add here the another function. I will try to show you that. Suppose I take a variable and give this variable name is the study area, and simply use here this variable, and it will be clipping with our shapefile. Our shapefile variable name is ROI. I simply use here the ROI. Okay, then I simply copy this variable name and paste here, and then click to the run. Okay, so now it will be clipping with our shapefile. So you can see this is our final product. It will be appeared, and now we can easily import this as a tip image, and we can easily make this map layout for using our ArcMap software. So here I already download these tip images from here, so we can easily download this tip image. I will try to show you that from here. So when you download the any shift image, you can simply
if you don't mind, I have a small question.
Yeah.
As you see that some areas are still showing in black. Does that mean there is no data, or because the minimum and the maximum are certain range, this is why you see that?
Yeah, actually in this time here you can see some places are the blank, because this image has the no data. Actually this image has, suppose that this place there is the no methane gas will be not available here, or it can also happen for the there is the no image will be capturing in this time in here. So that's why it will be some black portion will be available here.
I see. Okay. Thank you.
So now you can see I want to check from the inspector tab. Suppose I simply click to here and I click on this part. So here you can see for this red portion you can get here the total 909. You can see 909 for ppb. This is unit is the ppb, parts per billion. And if you want to check, click to here, we can get from here the you can see 1881. Okay, we can get this result from here. So now we can easily import this map. Suppose if you can see I simply use here the 1st January. If you need this for the February, you can just change this date in here, just put here the February. If you need here the March, you can just simply change here the March, then we can get this result. And in this time you can see here I can get calculated the mean result. Actually it calculated the total 197 images mean pixel value or average pixel value it calculated. Okay, suppose you want to need for here the median pixel value or total pixel value, then you can simply use here the sum function. Then it will be calculated the total 197 pixel images total the sum pixel value. If you want to need the median, then you can simply put here the median pixel value, median function. Then it will be calculated the 197 median pixel value. Then it will be showing your result in here. Okay, so I hope you understand this part. So I simply use here the mean, and now I want to try to show you that how you can easily import this map and work with the ArcMap software. Okay, so for this I simply write this code. You can simply use a function when you export any tip image. We can simply use here the export dot image to drive. Okay, I simply use this function, then I fulfill all of this argument one by one. So your first argument is the image. I simply make a dictionary. So for making the dictionary, here we use the curly bracket between two sides. Okay, I simply use the between two sides. I simply use this, and then first of all image. So image, this is the keyword. I simply paste here the key value. So image keyword, and the key value is that which layer I want to show here. In this time I showed this layer, it's called the study area. I simply copy this variable name and paste here. And description can be anything, so just a name of your file. Suppose in this time I simply use the cs4, Okay, then folder, which folder, suppose you want to create a folder, this folder will be automatically created in your Google Drive. Okay, it will be automatically created in your Google Drive, and then you can simply go to your Google Drive and you can easily download this tip image and make this map. So I simply put here this folder name is the ch4. Okay, same folder name. File name prefix not needed for this time. I simply remove. Dimension are needed. Region is needed because region, you can see our region is our shapefile and its variable name is the ROI. I simply put here the ROI, and then scale is also need, because scale I can simply put here the resolution of the satellite imagery. So I can simply get the resolution. You can see this resolution is that 1130.2. I simply copy this number and paste here, and then CRS not needed, class not needed, max pixel is needed. So when you work with the big region or your boundary is big, then we can simply use here the big value is the 1E13. Okay, all needed and is not needed for this time. I simply remove all of these things, and then I simply click to the run. You can see our task tab will be running. So I can see task tab will be running. So I simply click on this task tab and simply click to the run. So now it will be automatically downloaded in our Google Drive. After completing this, we can get the tick mark sign like this, and then it will be automatically download from here, and we work with ArcMap or QGIS software. So it will be loading here, and you can also see here when you work with this in ArcMap, then you also need to add here the shapefile of this Kuwait. Okay, so we can also download this shapefile of the Kuwait from the Google Earth Engine platform. So I already discussed, write this code in here, you can see. So this is the same code in here. So now you can see here, I simply click to this link. It will be automatically downloaded our Kuwait country boundary shapefile. Okay, it will be loading. You can see it will be downloaded as a Kuwait, as a zip file. Okay, I simply open this. I simply open and unzip this file. Unzip. And then I simply use the shapefile in my ArcMap software. I just paste here. Okay, so here you can see this is our country boundary shapefile, and now I want to make this map using these tip images and get the map layout, and I can easily use this map layout in our research paper or other presentation work. Okay.